Imagine standing at the edge of the ocean. You toss a pebble into the water. A ripple forms, expands outward, and slowly disappears. It feels small, harmless, temporary. Now imagine that pebble is a fishing net, or a plastic bottle, or a cloud of carbon dioxide rising invisibly into the atmosphere. The ripple still spreads, but this time it doesn't disappear. My infographic explores how everyday human activities accumulate into biological consequences for marine ecosystems, and how those consequences are reshaping life beneath the waves. The ocean covers more than 70% of our planet. Through microscopic phytoplankton, it produces over half of the oxygen we breathe. It absorbs roughly a quarter of global carbon dioxide emissions and more than 90% of excess heat trapped by greenhouse gases. It regulates climate, it stabilizes weather systems, it supports millions of species, many still undiscovered. For centuries, its scale made it seem indestructible, but scale does not equal invulnerability. Since the Industrial Revolution, atmospheric carbon dioxide levels have risen dramatically. The ocean absorbs much of this carbon dioxide, which reacts with seawater to form carbonic acid. As a result, average ocean acidity has increased by approximately 30%. That number sounds abstract, but chemically it means less calcium carbonate, the essential material corals, mollusks, and certain plankton need to build shells and skeletons. A small change in pH, a structural change in ecosystems. Coral reefs, which support nearly 25% of all marine species, are now experiencing repeated bleaching events due to rising sea temperatures. When corals bleach, they expel the symbiotic algae that provide them energy. Without those algae, reefs weaken, biodiversity declines, and entire communities lose protection from storms and erosion. At the same time, human harvesting intensified. Modern industrial fishing fleets can remove fish at rates far beyond natural reproduction cycles. According to global assessments, many fish stocks are either overexploited or fully exploited. When predator populations decline, such as certain shark species, which have dropped by over 70% in some regions, food webs shift dramatically. Predators regulate prey. Prey regulate smaller organisms. Balance maintains stability. Remove one level and pressure spreads across the system. Marine ecosystems function as networks. When one connection weakens, others strain. That is the ripple effect in motion. Now, this is not just about decline, it is about extinction. The stellar sea cow was hunted to extinction within just 27 years of its scientific discovery in the 18th century. The Caribbean monk seal disappeared due to centuries of overhunting and habitat disturbance. The Chinese paddlefish, one of the largest freshwater fish species in the world, was declared extinct after overfishing and dam construction disrupted its breeding routes. Each extinction followed a similar pattern. Human pressure increased, recovery could not keep pace, and the ripple became irreversible. Nature is resilient. Some fish populations have developed tolerance to polluted environments. Certain microorganisms capable of degrading plastics have emerged. Life adapts when it must, but evolution unfolds across generations. Human-driven environmental change has accelerated within decades. The question is not whether marine organisms can adapt, it is whether they can adapt fast enough. There is, however, measurable hope. When marine protected areas are established, fish populations rebound. When overfishing is reduced, ecosystems stabilize. When emissions decline, warming slows. The ocean demonstrates remarkable resilience when pressure is relieved. The ripple effect works in both directions. Damage spreads outward, but so does restoration. For centuries, we believed the ocean was too vast to fail. Now we understand something more complex. It is vast, yet vulnerable. Every product we consume, Every energy source we depend on, every decision we make as individuals and societies, each sends a ripple across the surface. And beneath that surface, life responds. The question is no longer whether we shape the ocean. The question is, what kind of ripple will we choose to leave behind?